We'll turn now to the second portion of this lesson about neurological interventions, which means interventions in the human brain. The role of data science is even more front and center in this than it was in the gene editing discussion for two reasons. First of all, if the vision comes to pass, it would require the real-time processing of huge amounts of data. And secondly, some people, including Elon Musk, see this path as eventually augmenting the human brain with AI capabilities, which is meaning AI or data science in the brain. We'll concentrate on Elon Musk's Neuralink project, as it's both the most publicized and the most audacious one out there, and involves the issues that I've just mentioned. But there are other people working on similar, more restrictive projects, and we'll mention a little bit of that as well. So let's turn first to the article, Elon Musk Wants to Read Your Brain. This is about, again, the project Neuralink, which is a way to connect the brain directly to devices. So it's a form of what's called a brain-computer interface. Let's start with the vision, which is not yet a reality and may not be one for a long time. We'll see. So the vision is that one would be able to read brain signals directly via thin implants that are implanted in the brain, and that those signals would then be transmitted wirelessly, I think, I'm not sure, into commands that would cause desired functions to be carried out on a computing device. So your brain, through these implants, would be talking directly to computing devices. The article summarizes Musk's vision for this, and I'm going to read a little bit of that because it's a good quote. Eventually, Musk sees a future in which anyone could opt into getting one of these interfaces and achieve what he calls, quote, symbiosis with artificial intelligence. Musk envisions an elective brain surgery that would be minimally invasive and take just a few hours, similar to a modern LASIK procedure. With such an interface, he says people will have the option of merging with AI, an area of particular interest for Musk, who has warned about the existential threat that even more powerful AI could eventually pose to humanity. I should stop there because that's an important part of why at least Musk is doing this. As you probably know, there's a cadre of people who think that computers with AI will eventually get enough of intelligence of their own that they'll get ahead of human beings. This is sometimes called the singularity, and that we have to prepare for that eventuality. There's some very intelligent people who feel strongly that this will not happen, and there's some intelligent people, and Musk is one of them, who thinks it will. And so that's what he's talking about here. Now, talk about ethical issues. That's a doozy because, first of all, we as computer scientists, data scientists, and other technologies have created the AI that might lead to this situation. And then for the people who think it's going to happen, they're talking about the things that we might do because of that. And then you have to look at the ethics of those things as well. To bring this at least a little bit further back down to earth, there are some initial potential applications of the Neuralink approach that are more focused and probably less controversial ethically. The one that's discussed in the article is allowing fully paralyzed people to control computers at the rate of 40 words a minute, which is 4 times faster than current interfaces will allow. And the extension of that would be the eventual hope to allow people with disabilities who can't speak or hear or see to be able to do that. All of that is likely years away. It should be mentioned that there are things that are related to this that are going on already. For instance, the United States Food and Drug Administration has approved what's called deep brain stimulation, which is a type of implant that produces electrical pulses in the brain. And this is being used already to treat Parkinson's disease and a few other conditions. But it's a very different sort of thing. These are not devices that transmit signals out that control computers. They're devices that produce signals within the environment of the brain. that comment about what is being done adds to the perspective that there has been research on brain-computer interfaces going on for decades, a lot of it aimed at allowing severely paralyzed people to control their limbs. And there has been progress about that, and you perhaps have read about some of those things, but it's still far from being practical. It also would be expected to involve invasive brain surgery. And as we said before, Musk is envisioning non-invasive, as it said there, almost a LASIK type of surgery, although the article also says that the ability to do this in a non-invasive way is probably many years off. The development that led to the publicity around Neuralink at the time of this article was the production of this very thin polymer thread that could be inserted into the brain. And there's a couple of interesting comments in the article about that. One is that while you can produce that, we don't know yet how well that thread would hold up in the brain, which is characterized as a hostile environment for something like that to live. The second was a very interesting quote from a Georgia Tech researcher who said, and I'll quote it, "Getting the brain signal is not hard. When you have the brain signal, what does it mean? That's the hard part." So what are the ethical considerations? As in the gene editing, they're immense. At the highest level, they really amount to what sorts of interventions are ethical and which aren't. And we're going to look at that and discuss that right after we talk about the next article. The next article from CNBC was written nearly 1.5 years later than the Neuralink article. In fact, very recently before I taped this, and provides a little perspective both from that extra time and from drawing on the insights of other scientists. I won't go through it in as much detail. I'm just going to mention what I saw as a few interesting points, some of which reinforce things that were mentioned before. So one of those is that brain-computer interfaces have existed for several decades, and they've been focused at specific conditions such as paralysis and Parkinson's disease. In fact, the article mentions that over 300,000 people have some form of neural interface, generally a chip implanted through brain surgery. So this does exist, but as we discussed before, it's a much more focused, more limited, and less powerful sort of interface. To me, the most interesting scientific point that was mentioned in the article was the comment that we still don't understand the brain all that well. And so the perspective is that even if we can get the signals out of the brain, we will need to understand the brain a lot better than we do now before that would be really useful to us. And then finally, it quotes Elon Musk as saying something that we've already mentioned, but I think is worth hearing again. He said, "I created Neuralink specifically to address the AI symbiosis problem, which I think is an existential threat." So where does this leave us scientifically and ethically? As we've heard, the ability to tap into the brain and understand it well enough to really impact its capabilities in general is a long ways off, and who knows whether we'll achieve it or not. But let's say that we could. In that case, what sorts of changes are ethical and which ones are not? So let me give a few examples. If we could cure conditions like ones that have been mentioned, such as paralysis or Parkinson's, maybe epilepsy, or maybe things like schizophrenia or bipolar disorder, would you do that? I think most people would say yes. I think we could still get into the feature versus bug discussion in some cases. But now let's take this to a totally different level. Let's say, and this is even more speculative, that we had the ability to take any person who has a below average ability in math or in language or in another form of learning and move their capability up to what has been up until this point be an average level. Should we do that? This is grossly speculative. Maybe we'll never get to that, but that's the sort of thing that this at least invites us to think about. And even that falls short of where Elon Musk is going, which is if we have the ability to augment our human brains with the sorts of AI, machine learning, deep learning types of capabilities which computers have, would we do that? And of course, who gets to decide? And where do we, as data scientists, whose work is essential to achieve any of these things if they ever get achieved, where do we fit into that? And that leads to the final thing we're going to do in this lesson, which is to have a class discussion on exactly those sorts of issues. What I'd like you to each do is to write on the discussion board an answer to each of the two following questions, which will now come up on the screen. So the first question is, under what conditions do you think it is okay to change the capabilities of a human being via gene editing and/or neurological intervention? For example, diseases that significantly impact the length and quality of life, conditions that make certain people less physically or mentally capable than others, creating AI-enhanced superhumans if we ever can. What is the basis for your opinion? And there's no ground rules there. You can make that basis anything that you want it to be. The second question, which gets back more to our roles as data scientists, is for these interventions to progress and succeed, significant involvement from data scientists will be required. What do you think the stance of the data science community should be with respect to doing such work? This could include whether or not or under what conditions you think data scientists should work on these problems, what obligations you feel the data science community has to be part of the broader ethical discussion on these topics, or any other aspects that you think are important. What I'd like you to do is answer each one of these broad questions, give about a paragraph or two answer to each one of the two, and then, as you've done before, find an answer to each one of those from a fellow student that you would like to comment on and make that comment. In the next and final lesson of this course, we'll turn to the somewhat related topic of the future of work.